So how Hashmap works internally? That means how Hashmap stores the elements internally. So that is the one I'm explaining here. First, create object for Hashmap. So when internally happens, when JVM creates a new Hashmap, first you have to create object for a Hashmap class. I'm creating object, see, Hashmap, see, you are specifying key data type string and value data type also string. That means both should be a string. So map, now there is 16 buckets. I told you the capacity of a map is 16 buckets. Like this, 16 buckets will be there. So once you create this Hashmap object, the heap area, 16 buckets will be created. Now, only 16 buckets, then what will happen if load factor crosses 75% of its capacity? So it filled here. Till all the elements are filled. Then what about next? So another 16 buckets will add. 3/4 is filled. 75% is filled. Immediately another 16 buckets will add it to this memory. It keep on increasing. If more elements are coming, the another 16 buckets keep adding. The memory will be grown automatically. The size will grow automatically. That's the collection, right? It's not a fixed. So size is not fixed in the collections. So it will grow automatically. So that's how it will store. And another thing is here you need to understand the linked list concept. So I explained linked list there, right? Linked list stores data in form of buckets. See, linked list stores the data in the form of buckets. Bucket is nothing but a linked list. Bucket is nothing but a linked list. In linked list, one node pointing to next node. See, the link is happening. One node pointing to another node. This node pointing to another node. This node pointing. This is linking. That is called linked list. So what is a linked list means? Linked list one node pointing to other node. That's a linked list, the way it will store the elements. So when you add nodes to linked list, it will keep adding. So add first element. Then it will add to the next link. It will link to the next element. This, it will link to the next element. That's the linked list, how it will store the elements. And the internal structure of Hashmap looks like this. See, first bucket is the first bucket. The bucket inside there are a lot of linked list structure. Second bucket, another linked list structure. Third bucket, another linked list structure. So like these 16 buckets. Every bucket is having a linked list structure. Each node is one element, one key value pair. One more is there, so another same memory address comes. This first memory address, second memory address, third memory address. So it will go and store here, and one more node will add extra. So let's see that I'm going to give very nice examples. Let's see here. Jim will take the put method key value to store the entry into the map, right? Put method we are using. First, what it will do, calculate the hash code of the key. Then in step 2, find the index of the hash code. For example, you are using a put method to insert element, right? Map.put. This is the key and value. Now, first step in the finding out in the 16 buckets, which bucket it has to go. How it is finding out, I'm giving, please understand here. Finding out the bucket, which bucket this key value pair should store, I'm giving. First step is, it will take the key and find the hash code of that key. Suppose you got hash code 2236 integer number, right? Hash code means nothing but integer number, right? Memory address. So this hash code memory address is this one. Now, second step. Using this hash code, it will find the bucket index. How to find the bucket index? Hash code ampersand length -1. length minus 1 is 16 minus 1, right? So that will find out the bucket index. Suppose you might got the 12th bucket, you got it. Now, 12th bucket, this key value pair will go and store there. That's how it will go and store. That's what I told you. Hashmap is unordered. It doesn't give insertion order to you. It will go and store in the memory base. So it will find the bucket and that will go and store there. So now it got the 12th bucket. So in the 12th bucket index 12 you got. Now this map.put method will put that in the linked list first node. It will store like this. This is a linked list first node. First node contains key value. That's how it will store. Now these are all empty now. These are all empty. But first it will find out your first put method. The key value pair is in the 12th bucket. Not necessary. Always it will, the procedure you remember. First it will find the key hash code. You will get the one integer number. Second step, using that hash code, it will find out the index, bucket index. Using ampersand hash code, ampersand size minus 1, length minus 1. With that, it will get the bucket index. The second step, you will get the bucket index. On that bucket index, it will store as a linked list. Linked list means one node, right? In that node, the key value pair will store. Okay. Suppose take one more put method. Okay. One more key value pair. Map.put LD B. So what it will do whenever you are calling put method, first it will find the hash code of that key. It will find the hash code LD dot hash code. You are calling the hash code method on that key, right? You are calling the hash code method on that key. You will get the hash code value 2424. Now, second step, find the bucket index. Suppose you got a bucket index 8. Now, what will happen? So first, key value pair is in the 12th bucket. Now, second key value pair is going to store in the bucket index 8. Now, it's stored here. So this is the one linked list. This is the another linked list. The second bucket. Okay. So you understand now, right? How it is storing the values. Are you clear? Are any doubts here? I'm moving a little bit complex step. That's why I'm asking. So are you clear on how it is storing?
Yes, sir.
Okay. So let's move on now. Let's take one more data that is going to teach hash collision. For example, you got a next key value pair entry in the same bucket you got, the bucket you got. Now how it will store? Already, so 12th bucket one key value pair is there. If you are getting one more entry with the same bucket index you got, then how it will store? That is what I'm going to show here. So hash collision concept, I'm going to another interview question. What is hash collision? They will ask. So the hash collision is nothing but the bucket is having already one node, one linked list node. And again, JVM tries to place one more node in the same bucket. That is called hash collision. What is hash collision? The bucket is having already one node. And again, JVM tries to place one more node in the same bucket. That is called hash collision. Now, suppose take a one more key value pair, a map.put method, EAC. EA got the 2236 and the bucket index, you got a 12th bucket. Already 12th bucket, we placed one node. And next, FB we placed already. And now EA also getting the same bucket index. Now how it will happen? Now how it will store? First, what it will do, JVM checks if same key is present in the bucket or not using equals method. If same key is present, then JVM will update the existing key with a new value. Please catch here. You got the same bucket. But there is already one entry, right? First, it has to check if the key is the same in the bucket or not. How you can check? Using equals method. So equals method is called and check that same key is present in that node, in that bucket index, in that bucket or not. Then if it is find out the same, both keys are same, then the key value will be updated with a new value. Previously you entered some value. Now you are entering with the same key another value. That new value will go and store there in that 12th bucket. So suppose now see think of two strings. Already FB is there, you are entering one more EA key. It will check, it will call equals method. EA dot equals FB. True or false? EA dot equals FB. True or false?
False.
False. False means so it is not same. That means it will store in this node. That means one more node will add here. This linked list will grow here. If the existing key is not equal to new one, then the new data will be added to the same linked list as a second node. Now you can see linked list is growing now. So in the second node, this EA and C will go and store that. Because previous key and the new key both are not same. So both are not same. If both are same, it will update the value. If both are not same, it will add a new linked list node in the same bucket.
But is it, how does it work with the load factor and the number of buckets?
So load factor, it doesn't work. Load factor means it's the number of 3/4 it filled automatically it will recognize. So but your linked list will keep growing. But not the buckets are not filling, another bucket is not filling here. Same bucket is filling with another
It's
link.
growing.
Linked
Yeah.
list will grow.
Yeah, got it.
Your linked list will grow, but not the map size. Map size is not growing.
Yep.
So your linked list is growing here. If same bucket, if it gets. So, and another one. So summary of entire this is the output method will work and it will put the entry there. So see that I'm complete things I'm giving here. When you call put method, first hash code method will call on the key and you will get the hash code value. Then second step, based on that hash code, you find the bucket index using this formula. Once hash collision comes. Hash collision comes means this one, it will go to this path. If hash collision is not coming, so then simply add to the linked list as a first node. Hash collision is there means what? So same bucket you got it. If hash collision is not there means another bucket, right? It will go and add the first node. Like 8th bucket we got in the fresh one node will add there. If hash collision happened, same bucket index you got. Previously one bucket and this same bucket you got. Now key already present. So key dot equals existing key, both will compare. If both are same, what will happen? If both previous key and existing keys, existing key and a new key both are same, what will happen now? It will replace the existing key value. Key is same, but value only replaces, new value will place in the same bucket, linked list node. If no, another linked list will add, another node will add to the linked list. So this is the how it will go completely. So how searching will happen in the linked list is one by one node will search. That is the drawback of linked list. For example, I want item 3. So first it will check item 1 equals item 3. No. Next it will go item 2 equals item 3. No. Again item 3 equals item 3. So this will fetch for it. This is how it will search in the no linked list. So that's what it will be performance issue. Linked list is basically a performance issue because you're starting from the first to last. So that's the problem. That's why linked list is performance bit slow. More linked list is adding means performance will degrade. So that's the how linked list will store the elements, how it will fetch. How it will fetch? Again, same. How will you get the key value in the hash map? You have to use a get method, right? That method you have to use to get the given key value. So map.get EA. First find out the hash code of the EA, and you got that. Then second step, it will find the bucket index, 12th bucket. It will check. So the first, right? First it will check get the key you are giving. So first it will check here in this first node. This key is there in this node? No, it will go here. And it will be available here. Then it will return this value. So this is how it will get the value by get method. So for example, in the same bucket, multiple nodes are there. Linked list, right? This is the linked list. It will fetch that values. So the get method will get the given key and you will get the C. Here, this method will return a C for you because you are giving the key and returns the C for you, not A. Because you are giving the EA value is C. So C will return to you. So this is how the map will store the elements and it will get the elements. So that's how internally Hashmap works. How internally Hashmap stores the data. Okay, so that's it for the day. Please read this